Welcome back, everyone. So today we'll talk about Bash, terminal, and a bunch of other Linux-related command. We'll run a bunch of them and interpret them, right? See what they look like, what their output is, understanding what they're showing us on the screen. So one of the term that you might hear a lot is something called Bash or terminal. Whenever there's a conversation about Linux, right? So shell is basically a vehicle, all right? It provides a mechanism for us to interact with the OS itself, right? So shell is a command language interpreter. It provides the interface between the user and an operating system. So when the user logs into the OS, it starts a shell for the user. So we use the shell to send our commands, right? Tell it what to do. Right? Shell is available for both RPM and Debian-based Linux. Remember that. So those two are not the only variants, right? There are Slackware, Gentoo, Arch Linux. They use their own package management, but nonetheless there's a shell environment for all types of Linux, right? So what does shell allow us to do, right? It allows us to run programs, manage our files, copy them, move them, right? Delete, create new files, compile computer code, manage the computer in general. So in Linux, it is pretty flexible and robust. You can nearly do everything using the terminal, right? As a matter of fact, most of the Linux server OSs are command-based, right? There's, usually the GUI is not installed, right? If you want a GUI, you have to explicitly go back and install it. It is done for a couple of reasons. One is performance, right? Less programs, less overhead, and also in terms of security. It improves the security footprint by not having the GUI, right? The machine performs better, faster, and it's more secure that way. Even Microsoft is, promoting the idea of using their the core version, which is a GUI-less version of Windows Server. The option is there, right? If you want the GUI, you have to go back and explicitly add the GUI. So in Linux, there are some other shells, other shell variants: C shell, Corn shell, and Ash. So all of them are used as a mechanism to interact with the OS. There are some subtle differences. For the most part, if you're scripting for each of them, they're slightly different, but nonetheless they all provide the same functions, right? You tell the computer what to do, and it runs the command. So that's what a shell does for the most part. So some sample commands, there's a whole bunch of them, starting with the Debian-based command. We'll have a look at some of those. As a matter of fact, let's connect to my system. Okay, so I just logged into my CentOS VM, and I'm going to run some commands. Now, remember, this is CentOS, which is Red Hat based. So that means I cannot run this, right? So apt-get is specifically Debian or Ubuntu. That's a command for Ubuntu or Debian, right? Not for Red Hat. But I will try to run another program, something very simple as state. How about that? Or cal, right? I can also do ls, show me a list. Okay. So you can see a bunch of sample commands, their description, and the proper syntax. So as we run more and more commands, you will see that Linux is case sensitive. The ordering and the case do matter, unlike Windows, right? So just to show real quick, if you type this in Windows, is the same as this. So all these variants and iterations are exactly the same in Windows, but not in Linux, right? So in Linux, H3 would be unique. Okay, so even though it reads the same, they'll be treated as unique entities in Linux. In Windows, they're all the same. So one thing to keep in mind, right? Or when you SSH into your session or log into your session by default, right? You'll notice that there's a little $sign, right? What's that telling you is that you're logged in as a normal user, right? You can run basic commands, anything that requires privilege, such as installing new software, performing software update, and things of that nature that will require privilege. So in order to change your privilege, your account must have that rights, and if you do, and you're able to successfully authenticate, and then you'll notice that that $sign will change that to a hash sign, right? So that indicates you're now a privileged user, right? So you can run pretty much anything you want on that system. So that's how you would know, right? So the $sign indicates you're a normal user, and the hash sign indicates you're a privileged user. Okay, so some more commands, and let's actually try to run them live. So at the top, there was a screenshot of some basic commands that I ran, and here's the table. So let's go through some of them. So this time around, I'm actually logged into a different machine, right? You can see the host name, and the screenshot is from a different system, but I should be able to run the same. So let's do cat, let's see, pass, let's sort it. How about that? So notice when I was typing this, right, I can simply press the tab key for auto completion, right? So it does it for me, and then I just have sort, okay, and then press enter, right? So I see a bunch of stuff, right? I see the output of the this file, right, in alphabetical order, right? Lots of stuff, but I want to look for something specific, right? So I'll take the same command, but just change it and use the grep utility, which allows me to search. So I'll search for, let's say, the word pulse, right? So when I was looking at the whole content, right, I saw that line, right? Okay, so when I do when I run this command with the grep, there we go. Okay, so now instead of looking at the whole file in its entirety, I'm only seeing that specific line with my specific term that I was searching for, right? And you can see that it was also highlighted. So grep, and that's because of grep, right? So this is a great utility that lets you find things, right? So that's just one example of searching or piping commands actually. So I'm chaining commands here. Let's look at another example. I use the lsof utility. Okay, so that would have checked for TCP and UDP open ports. So it looks like I don't have any network activity going on at this moment on that system, which is why you're not seeing an output. But if I get rid of the additional parameters, right, I see a whole lot of stuff. So in my first attempt, right, I was specifying certain elements, right? I was looking for specific things, and that was not happening. So now that I run this in general, right, I get to see everything, but I can still grep it, right? Grep for let's say, obviously that has my username. Let's try something else. How about that? Okay. Still a lot, but you get the idea, right? It'll look for the specific term that I'm searching for, and it'll show me everything with that. Some more sample commands, very useful commands to see information about your system. For example, your host name, the Linux version name, right? Very simple commands, very easy to run, right? Doesn't require any additional parameters for the basic output. Okay, so here I have a specific example showing that the case matters, case and the ordering, right? So this is something because Linux is very sensitive about that, right? So notice these two commands, right? If I change the H from uppercase to lowercase, it complains about this invalid option simply because in Linux, lowercase h is much different from uppercase H, right? So you can see additional parameters, symbols that you have to use. And this is very important, right? So this is the typical Linux folder structure. So the slash indicates the root partition, right? The root of that system. So that would be equivalent of the C drive in Windows, right? So under C drive, you have other system file and all the user files, such as program files, Windows, right? The users directory. Similar idea, right? So Linux doesn't use drive letters, right? It has the root partition, and there's a bunch of other subfolders under that, right? So these are the main ones, right? There can be more, of course, some custom ones, but these are the primary ones, and each of them have a specific role and purpose. So most of the the programs are found under bin and sbin. Any additional software that you install are likely to be in the OPT directory, right? The etc is very important, right? That includes host-specific system configuration, right? So temp will contain the temporary files, right? The user directory contains folders of the other users of that system, right? So here's a rough analogy with the Windows system, right? How it kind of compares with the Windows and Linux file system. So it's not exactly apples to apples or oranges to oranges, but hopefully you get the idea, right? So as you can see in Windows, you have different drive letters. In Linux, we don't. Right? On the left, you can see another verbal explanation of different folder structures, what you might see, right? And equivalences in Windows. So you can think of the lshw as the registry, right? Because lshw in Linux contains all about all the configuration and all the parameters. In Windows, there's a registry key, right? There's a repository of all the registry key, which holds the configuration information, right? So bin and the sbin are similar to the Windows and System32 folders, and so on. So when you're working in the terminal, right, sometimes it's useful to rerun the commands, right? And these shortcuts are really useful because they allow you to rerun some of the commands without retyping them. So let's have a quick demo of that. I can simply run a history command, right? So that'll show me a numbered list of the recent commands that I just ran, right? So some of them are repetitive because I run them multiple times. That's okay. Couple of things, right? So if I know for sure I absolutely want to rerun the last command, there are two ways I can do it, right? I can simply hit the upward arrow, right? Run it that way, right? That's one way. Or I can simply type 2 exclamation marks, and that will also execute the very last command, right? So let's say from that list, from that history command, right? I want to run the cat command, which is on number 10, right? Or 11, right? So I type exclamation mark, and let's run 11, right? All right. So you see the shortcut. I simply issued that command, right? Which in turn showed me the full command, right? And this is the output. So this comes handy if you're, if you've already ran a bunch of commands and you're not sure, so you can look for stuff like that. Once again, you can get help from grep, right? So if you vaguely remember some of the words, right, so you can do that. For example, I want to see what cat related commands that I ran, right? So again, I'm seeing the ordered list, right? And this time around, I'm also searching for cat as well, right? So all the commands with cat in it, right? So very useful shortcuts, and some more examples of those, right? You've already seen the examples of piping, right? How I use them. So basically, you take the output of the previous command and you chain them together, right? So it can be done for multiple chains, right? There are other techniques also, sequential, background, and expanding. You can also save the output to a text file, right, using the greater than sign. So when you log in, right, or open terminal, close the terminal, there are configuration file behind the scene that gets changed, right? So depending on the on your activity, whether it's logging in, opening terminal, or executing commands, these files are changed and updated. So that would depend on your activity. The two types of variables are the shell variables, right, and the environmental variables. So environmental variables are variables that are exported to any new shell opened from the current shell, right? You can see them with the env command, right? The shell variables can be viewed with the set command, right? So those can be customized and specific to your setting, right? So here are some syntaxes and characters you can use to customize it. So at the top right hand corner, I have a mini example, and I can quickly demonstrate. Okay, so let's run this. But before I do that, let's look at my current prompt, right? So what I'm saying is here, my username, right? I'm at the system. Okay, so we're going to change that. So first we have to export it. Okay, so right away you can see it has changed, right? So let's tweak a little bit again. I'll add something else. How about I add the S? Okay, the shell name. So so right now I have the time and the shell name itself, right? So unlike here, which is the default, the username at that system, right? This is the list of parameters that can be used to customize the shell prompt here, so that you can get meaningful information or information that you might find useful. Bin was one of the very most important directories in Linux, right? Because it has most of the executables here, right? In that directory, and here's a sample of that. This is not the entire list of all the commands that exist in bin folder, right? But these are the most important ones. So each of them have their own syntax and parameter, right? So this is just the name of the of those executables. Some more examples of Linux commands, right? In the first one, we see how to unzip a file, right? So obviously we know we have software that can do that, GUI software, but you can also do it from terminal, right? Let's run this one. lshw can be used to obtain information on many components of your system, including your network, CPU, right? So it'll show you tons of details about your hardware. It's a very useful command. The dd command is very useful for forensic or data copying, right? curl is a network-based command for testing network connectivity. SAP is also used for transferring files from one system to another, right? So a bunch of really useful and interesting network-related programs here, and their basic syntax, right? So this is just the basic format. Obviously, they can be much more complex. So if you get stuck in Linux, right, how to get help? So man is your friend. So any command you want to know more about, you can learn. You can type. You can ask the man, right? Man. That's a host name. How about that? So I can read the manual about the host name command. I can see all descriptions, examples, the whole deal, right? So when I'm done, right, I can press Q, right, and get out of there. Now some programs offer the help option, right? It's not all the programs, but some of them, right? So the help menu will show you slightly different information from the man pages, right? And again, it would depend on the program itself. You have to try, right? So let's try for the same command. Host name. Right, so no luck there, right? So there are no content. So it's asking me to check with the man page. Okay. Again, so similar idea with the info, right? You can try, but it would depend on the program itself. But man is there. Man is very extensive. The help and the info commands can also be helpful, but it may not be available for all the executables, right? So that was a quick overview of some of the basic Linux commands and how to get help if you get stuck. But I think this list is very interesting, and these commands will be very, very useful for troubleshooting network issues, connectivity issues, security issues, right? So these are some hand-picked network-related commands that could be used to gather information, to do some basic troubleshoot or find the root cause. Thank you for watching.